Hi, welcome everybody. My name's John Jamie. I'm the VP of Marketing at Sedai. I'm here to introduce and moderate today's session. We're going to be talking about moving to AWS Lambda for development and operational efficiency. And I'm excited to be sharing with you the topic today. And as a bit of background as we go through the session today, please feel free to write in your questions into the chat as we go through the session. We'll cover the questions at the end. We've put time aside for Q&A. So wherever you're watching us, whether it's Zoom, LinkedIn, YouTube, or elsewhere, please feel free and just share your questions as we go. So I'll next introduce today's speakers. So very excited to have two people with a significant depth in Lambda to talk with you from both a development and an operational perspective. We're going to be hearing from Sandy Kumar, who's the engineering manager at NStack. NStack has significant experience working with companies to adopt serverless architectures, right from basically sort of ground zero and building up to significant scale. And we're also going to be joined today by Nikhil Gopinath, who's a VP of Engineering in ML at Sedai. Nikhil has significant experience on helping companies operate Lambda basically with an autonomous operations approach. So the serverless architecture already provides significant time saving, significant efficiencies to people building the applications, but it can also provides a lot of leverage as well from the operational side. And Nikhil will go over approaches of how to do that today. So next, let's just quickly recap the agenda, and then we'll get into the session. So we'll be covering some of the business case for adopting serverless, different factors to consider in adopting serverless, what types of applications and architectures serverless makes sense for example. We'll go through a methodology of how to migrate across to serverless, then talk about how to actually succeed in once you have adopted serverless, how to succeed from an operational perspective and an ongoing development perspective as well. Then we'll get into how to manage serverless autonomously. So it's a very low effort from an operations perspective to support the architecture, which is a key element of the overall efficiency of the architecture. Then we'll get into Q&A and then talk about next steps at the end of the session. So here I'd like to hand it over to you, Sandy, to take it from here.
Yep. Yeah. Hi everyone. Nice to meet you. So let's start with a small intro on what serverless is. So serverless is basically a type of computing model, a cloud computing model, where the cloud provider takes care of all the infrastructure management. And unlike traditional systems, we do not have to manage the infrastructure from our side. Most of it is taken care by a cloud vendor like AWS itself. So we don't have to worry about server provisioning. We don't have to worry about the capacity planning. All that is abstracted away from us. And what happens is we pay per execution rather than paying for the amount of servers that are running in the system. Serverless also brings in the stateless concept, and it also enables you to build event-driven applications. Now, at the core of serverless is Lambda. So Lambda is AWS's compute unit, which is a very small compute unit, which can run for up to 15 minutes. And you can allocate a memory up to 10 GB. And we'll be looking into what are the serverless benefits and how we can benefit, or what applications can benefit out of it, and how you need to be migrating your applications. So moving to serverless benefits. So there are two sides of benefits when it comes to serverless applications. First, we'll look into the business side of it. Then we'll go into it from the developer perspective, how it's going to help the developers to migrate to serverless. So the first thing is the time to market from a business perspective. So with serverless applications, you can build applications much faster than you would with a traditional infrastructure management. So with this, the amount of time it takes for you to prototype your application and make it live is much more lesser compared to the traditional system. That's where the faster time to market comes into the picture. Next, we iterate quickly and fail fast. So with serverless system, bringing up a new infrastructure and writing the code for it is much more easier, right? So you build your applications, you iterate, you see what is working, you see what is not working, and you have the ability to understand at a much faster rate what is working for your application and what is not. So you're able to iterate and fail fast at this. Next thing is from a growth perspective. So every business wants to be ready for the future, right? And that's also one of the reasons why you would want to move to serverless. It's one of the latest technologies, and you want to make sure that the investment that you make to build an application is paid off. So serverless comes with a lot of integrations, and the way serverless is built is to make sure that you're enabled for your future growth as well. So next we move to cost efficiency. So like I stated before, serverless is charged per execution of your limit. So for example, if you have a web application, in a traditional system, you would be paying for the entirety of the server running, right? So even if you don't have any clients who are using your website, you still have to pay for the machine itself. So with serverless, you pay per execution. So when a client clicks on an action and you need to call an API, that is the only moment you're going to pay for anything. So this drastically reduces the amount of cost you are incurred for a normal application. Next, with serverless, the other advantage you get is the minimal infrastructure management. So with in a serverless architecture, most of your infrastructure management is taken care by the cloud vendor itself. So you have very little infrastructure management to be done from your side. Of course, you need to allocate what are the Lambdas, what is their configuration and all that, but you don't have to worry about patching your Lambdas, or you don't have to worry about other vulnerabilities that are there in the system, because all your security is also taken care by the serverless vendor itself. So next we go into the reduced management overhead. So imagine you're creating an EC2 instance, right? So you have a lot of other services that you need to implement as part of it, like your networking services, and if you have any firewall services. So all this brings a lot of management overhead from a development perspective, right? With serverless systems, you have very little infrastructure that needs to be coded, right? So you can move faster and reduce the amount of resources you need to build a serverless system in itself. So next we go into the technical aspects of it. So this is from a developer perspective, what are the advantages we get out of a serverless system? So first, of course, is the simplicity of infrastructure. So like I said, the amount of infrastructure that is required for a serverless system is very less, and it is much more easier to set up an infrastructure or a serverless infrastructure from scratch, rather than traditional architectures like a container-based system or an EC2-based system. Next, we come to the scalability. The scalability and high availability aspects of it is mostly taken care by AWS itself. So every AWS serverless service has a limitation, or they have specifications on how much it can scale and what are the availability aspects of it. So for example, for a Lambda, the soft limit is you can have 1,000 concurrent Lambdas executing in a specific region, right? So all this is again taken care by AWS itself. You will not have to write any infrastructure code to manage these 1,000 instances. You just have to mention how many of them need to be consumed, and that's pretty much it. Next, we reduce the blast radius. So what I mean by blast radius is, in a traditional system, if your server fails, all the systems that are connected to the server will also fail. But in a serverless system, you break down your application into small pieces. So each API is basically running on a Lambda, right? So if one of the API fails, the amount of failure happening in the system is very less, and it's isolated to that particular functionality rather than your entire system going down for some reason. Next, we move into event-driven architecture. So one of the benefits you get by adopting serverless systems is you can build event-driven systems, like asynchronous systems, which are completely event-driven. So for example, the simplest one is you connect your API gateway to a Lambda, and anytime somebody invokes that API, only then you invoke a Lambda to get the functionality done. Similarly, you can have multiple events like cron-based jobs. You can have when you upload a file to S3, or when you upload a file to one of the storage systems, you can have a trigger that takes care of some action. Similarly, you can also have it on database systems. So let's say an entry got updated in the database, and based on that, you want to do further processing. So all that kind of event-driven architecture is possible in serverless, and all that is seamlessly done with the help of serverless architectures. Next, we go into polyglot programming. So there's been a lot of hype about AI, and pretty much every company wants to introduce AI into the system, right? And given that a larger number of the developers are still on JavaScript or Node.js, and the AI-based systems are mostly driven on Python-based systems, right? So this is one of the use cases where you can introduce a polyglot programming system where some of your Lambdas or a specific team develops Lambdas which run on Node.js, which is primarily consumed by the web application. And you can have another team which is working on the data science or the AI-related systems, which for which they're using Python programming. So all this will be managed by two different teams, and you can have APIs exposed, which kind of abstracts what language it is, and all this can be seamlessly consumed by the front end.
Sandy, quick question here, right? So given these benefits, are there certain kind of organizations that are better at taking advantage of this? Like, is it better suited for a startup, or is it suited for enterprises, or is it anyone?
So it is basically anyone. I think it depends more on the use case rather than the type of organization. But over time, we have seen a lot of adoption coming from the startups rather than the enterprise, because the enterprise systems are large systems which are tuned to run in a specific way, right? So for them to move to a newer technology comes a lot of complications from the management side as well, to try and get and convince the investors, and all these things come into picture, right? But for a startup, you want to build fast and you want to make sure your application is up and running. So serverless is kind of a startup is the best way for it, but it doesn't stop enterprises also. And in the next slide, we'll be looking at some of the use cases. These are from enterprise companies that have adopted serverless and what advantages they got by doing it.
Sure.
So,
thank you.
Yeah. These case studies are also available in the AWS website, so feel free to visit them. So these are some of the unique case studies and which are focused around serverless. So first one is Taco Bell. So Taco Bell is a large restaurant chain. They have about 7,000 restaurants in the US alone. So what they did is they built a serverless pipeline, which is going to take care of all the processing from when a customer orders to a restaurant to when the food is delivered to the customer. So this entire operation is going to have a lot of asynchronous events, is going to have some kind of manual intervention. So all these systems all these architectures was possible only because they use a serverless system. And they use things like Lambda, API Gateway, EventBridge, all these other AWS serverless services to kind of help them into moving into a serverless system. They also built a data integration platform which can handle large, so all the 7,000 restaurants also had a unique menu for each of these restaurants. So this data integration platform, they were able to provide unique menus for each of these restaurants and add customizations on top of it. Next, we go to Liberty Mutual Bell. So Liberty Mutual is one of the largest insurance providers in US. And what they did is they built a ledger system. They call it Financial Central Services. So what this does is at the end of every month, they had a large number of records to be processed. So kind of like an audit. So what they did is with this FCS, they are able to process about 100 million transactions at the end of the month. And every million transaction was costing them only about $60 to do it. And Liberty Mutual has also claimed that by moving to serverless, they're able to build applications at a much faster rate than than the time it would have taken them on-prem. So they say that building it with serverless, they were able to do it in 3 months, the same thing that would have taken them about a year to do in a traditional system. So next we go to DBS Bank. So DBS Bank is, I think, one of the Singapore banks. So what they did is they built a completely serverless compute grid, and they use it for all kinds of model analysis. And they're using it mainly to focus on forecasting trading systems, right? And they're running about 40 million transactions every single day to enable the forecasting for all their clients. So they also have different priority queues. So they have different priority queues for each of these clients. And based on the priority, a particular serverless grid gets kicked off. And these Lambdas do the computing, and then the information is sent back to the client. Next, we go to Capital One. Capital One is one of the largest banks in US. They started moving from a completely monolith infrastructure to building a serverless system. So what they started doing is they took small pieces of their application and moved it one by one. So this way, they were also able to prototype and test out what kind of infrastructure worked for them and which were the use cases that were best fit for serverless. So but by doing all this, they were able to save about 90% of their cost by migrating to serverless. And they also claim that it saved a lot of time for their developers. And again, like we also saw in Liberty Bell, one of the things that Capital One also said is building a newer application is now taking days, which used to take months for them previously. Next, we go to CoStar Group. So CoStar Group is one of the real estate information and analytics company in the US. And they're using a serverless system to process every image that is incoming into the system. So the images or the videos of the real estate or of the properties is updated by a lot of vendors. And each of this image needs to be processed to add thumbnails, to validate them, or to do any other kinds of processing. So for all these events, they're using a Lambda-based system, which is going to read the image and process it and allocate it according to the user group. Currently, they're processing about 150,000 images, and they're probably looking to scale up to the next level as well. Slicky. Yeah. So next, we go into why you should move into serverless, right? Or when you should move into serverless. So now that we've spoken about the advantages of serverless, and we have seen some of the real life use cases on how the serverless needs to be done. Now we'll talk about the patterns or the things that you need to look for in your application so that it can be moved to a serverless system, and which will benefit you as well. The first thing is the variable workloads. So if your application is having a lot of spike, or if your application is having variable workloads, say, for example, a simple e-commerce website or a cart website, you're not going to be having traffic 24/7, right? You're going to have high utilization times. You're going to have low utilization times. So anywhere there's a variable workload, serverless is the way to go for it. Then you have industries like InsurTech. So if you take InsurTech InsurTech industry, the amount of times a client is actually going to use the system is probably once a year or twice a year, right? So for these kinds of systems, you would not want to have a server that is running 24/7. It's a waste of resources. So under these cases, serverless works best. So next is when you need event-driven processing. So let's say there are a lot of processings that needs to be done. So for example, when somebody uploads or when your financial team uploads the CSV into a specific place, you need to take that and start making records out of it, or generate PDF out of it, or send it to the next system for processing. So any kind of event-driven processing that needs to be done, serverless is the best way to go. Mainly because of all the integration capabilities that Lambda and other AWS services provide. Event-driven thing is one of the easiest things to develop in serverless. And over time, the observability market has also increased. So in case you upload a file to S3 and the Lambda is not able to process it, you have a lot of retry mechanisms. You have DL queues, which are going to capture the failed events and all those sort of things, which can be done with minimal configuration rather than you spending a lot of time on it. And one of the other use cases, which was also mentioned previously, is for image processing. So we had a client where once an audio file with an image is uploaded, we need to generate thumbnails out of it, and we need to send it to the right service provider. And each service provider had a specification as well, like the image size or the audio size. So all these things need to be taken care of. So what we did is, once the client uploads a file into S3, it triggers a Lambda, and that Lambda is going to identify what file it is, where it needs to go, and what are the other processing that needs to be done. And all this can be done seamlessly with event-driven processing. So next, we go into parallel processing. So now that you've split up your application, or you're splitting your processes into small chunks, you're able to parallelize it. So with Lambda, one of the advantages you get is you can use SNS on top of it to kind of invoke multiple Lambdas at the same time. So one of the use cases for this is we did a video streaming or video processing mechanism where once the user uploads a video file, we need to convert that into 33 different formats. Now, if you were to do the traditional way, the amount of resources you would require to parallelize this becomes massive. With Lambdas and other and a service called Step Function, we were able to process all of these videos parallelly and get the best out of both serverless and other services like Step Functions. Next is when you want high infrastructure flexibility. So one thing you can do with serverless is the amount of time it takes for you to bring a new system and destroy the system is very less. So any place you think that you need to bring up new systems on a daily basis. So one of the use cases is a PR system, right? So when you create a PR, you would want to see how that functionality is exactly working. So you could essentially bring up a completely serverless system on a specific PR, and you can log into that system and see all the functionalities and how it is working and all that information. So anywhere you want to be able to bring up a new system, destroy it immediately, and have all this kind of flexibility, you need to move to serverless. The next part is the integration with other services. So with serverless, it's way more easier to integrate with third-party services and other AWS services as well. So one of the use cases is we had a client who had an older system, like the system was running on .NET and other things, but they wanted to scale up their application. Now, because it's an older technology and everything is pretty much outdated, they couldn't find developers, or they didn't have the business case to build new services on top of it. But what we did is we built an integration hub, which is purely serverless. And this integration hub talks to all the other third-party vendors, like say HubSpot, PagerDuty, and their payment gateways. So all these integrations, right? So once we started doing this and gave them a way to interact with this integration hub, the client actually started building more functionalities for their existing system. So one of the big selling points of serverless is the way, or is the easeability of integrating it with other AWS services and other third-party services as well. So next is prototyping for new functionalities. So one of the very first thing that you do is to try out a new idea, right? So as soon as you get a new idea, or you want to try out, you get a new business idea, it's very easy to prototype in a serverless system because, again, like I said before, the time to market is so much lesser, and the amount of time it will take for you to develop this application is so little. So the moment you get a new system, or the moment you get a new business use case, the first thing you need to do is see if it can be run on a serverless system, because you can see the output faster and you can determine if that is going to actually help your business, or you can make other modifications on top of it. Yeah. So here we built a small application to show you the differences between an EKS system, an ECS, and a Lambda. So EKS is an Elastic Kubernetes service, which is a managed Kubernetes cluster by AWS. ECS is a managed container service by AWS, and Lambda is the serverless compute system. So we took a small retail demo app and ran it on all these three systems, which with the same functionalities and all the items. And we added different traffic patterns to it to see how much cost difference you're going to get. So from this table, you can see that Lambda is always at the lowest, even when there's high traffic into the system. And the difference is quite huge, right? So for the highest traffic, you have about $509 of billing on a Lambda, whereas in ECS, you have $2,015. So this is one of the main reasons why people move to serverless is the amount of cost savings you are going to get, especially for retail apps or any kind of e-commerce website where the traffic is pretty spiky, it's always best to move to serverless exactly because of this cost saving reason.
Sandy, in this comparison, right? So cost, definitely there's a huge benefit with Lambda. How about performance and development time and all the other aspects of building software?
Right. So compared to, let's say, if you were to build a Kubernetes cluster by yourself instead of using Lambda, again, that will add more time into development and all those things, right? EKS kind of abstracted to a certain extent, but still there's a lot of configurational work that you need to do for EKS and ECS. Whereas the amount of time you need to develop the same application in a Lambda is so much lesser than a traditional system, right? So your entire development time itself reduces. And one more main shift from a monolith system to a serverless system is the mindset of creating the API itself, right? So in a monolith system, you have a large code base, which is handling all the transactions. Now, instead of that, you have Lambdas, which are basically small code bases, which are isolated from each other, which are much more faster to develop, which have smaller failure rate as well, right? So it's much more faster. Anytime you split your code into smaller functions, it's easier to maintain and it's so much faster to develop as well. And in terms of performance, again, coming to the scalability aspect of it, the amount of scalability you get in a serverless system is always higher than what you get in traditional systems. Mainly because of the way AWS or any other cloud vendor is going to manage these infrastructure for us, right? So all we need to do is say how many concurrent sessions you want in case of a Lambda. And AWS is going to handle all this configuration for you and the scalability aspect of it as well. And you don't have to worry about how many users are there. So you have X number of users, so you need to provision Y number of Lambdas and all those things, right? Lambda will automatically scale up and down based on the demand. Whereas if you take an ECS or an EKS system, you need to have some kind of auto scaling mechanism to tell that your server utilization reaches say 70%, then you run another container system or run on the EC2 and all these things. So you remove all this work from your side and let AWS take care of it, and you focus only on the business logic.
Right, makes sense.
Right. Next, we go into once you have identified that you need to move to serverless, what are the other things or what are the steps that you need to follow to migrate to a serverless application? So first thing is to identify the use cases. So from the previous examples and also these advantages, you can see that one of the main use cases that you need to identify is what are the spiky traffic or what are the variable loads that you have in your system. So these are the best to move to serverless where you can see maximum results. The other parts of it is when you have high integrations in the system, when you have an older infrastructure that needs to be phased out or that is no longer supported. And that's the case with a lot of enterprises as well. So they would be running systems on SQL 2016 and all those things, right? So which is out of support and they need to move out. And when they move out, they would essentially want to move to a newer technology so that they don't have to worry about it phasing out. The other part of it is also your old code. So as your code increases and the amount of time you have spent on a system increases. So let's say you develop an application and it's about 10 years old at this point. And when it reaches that point, no developer will be able to identify what is going wrong in the system. So it becomes a black box and you're just hoping that nothing breaks. So these are all the places where you need to identify that, you need to move to a newer system and you need to move into a serverless system. After you have identified these use cases comes the architecture planning. So with serverless, of course, your infrastructure management is abstracted to a great extent, but you also need to plan how your infrastructure is going to look like and also identify what are the other services that are going to work with it. So for example, a Lambda can provide a payload output of 6 MB, but your API gateway will have let's say is going to be able to handle a payload of only 2 MB. then you cannot build your application based on that, right? So you need to know what are the limitations in your architecture and the services that you're choosing. And you also need to identify how these services are going to work with each other to have a proper system that's going to suffice your needs. So architecture planning plays a very important role in identifying with or in moving to a serverless system. Next is the code refactor. So like I said before, you cannot take a monolith application and just split it into functions and expect it to work in a serverless system. So your entire monolith code was written in a different mindset altogether. And in most of the cases, you would have to rewrite the code from scratch when you're moving to a serverless system. So you need to plan for that and look at the amount of code that needs to be refactored. You also need to look at the application and identify what are the actual business use cases that are currently being used and what you want to enhance. So you need to identify all the places where new code needs to be written and the old code needs to be phased out. Next is you build an MVP on these use cases. So once you have identified your use case and once you know what is the architecture you're looking at, and once you have decided how much code needs to be written for it, you start building the MVP for this. So prototyping is one of the fastest ways that you can convince anybody to use serverless. So it's much faster to do it on a serverless system, right? So you build an MVP on these use cases and start seeing the output of it. So you start running pilots to identify what are the gaps. You start running pilots to get early feedback from the clients. So this would be your next step in the serverless migration. Next comes the traffic movement. So you have a system that is already running on a monolith or container system, and then parallelly you're building a new system which is on the serverless architecture. So what you would want to do is, instead of doing a cutover from the older system to the newer system, it's always recommended to have a blue-green traffic movement, meaning you have most of your workloads still running on the older system, and you start moving traffic little by little to the newer system and see how the system is interacting with the users. And once it's all good and you're not having any issues, any errors, then you start moving traffic completely into the newer system. So next comes to the data migration part. So there are two ways you can do the data migration. You can either have a completely cut off migration, meaning you take all the data from the older system, have a downtime, and move the data into the newer system, or you can have a progressive migration. So one of the things we did with a progressive migration is, so like I said before, we built an integration hub for a client, which kind of enabled them to build new services on the older system. And what we also did is, when we built the newer system, we connected it to the same integration hub. So every event that was going from the older system was also being listened by the newer system. So this way, every event that was happening in the older system, we were tracking it and updating the newer system as well. So this way, progressively, we updated the newer system with all the existing information, and also new clients coming in were moved into the newer system as well. Yeah.
Right.
So now, yeah, Nikhil.
Okay, so yeah, take over, Sandy. Yeah. So hopefully at this point, Sandy has convinced you to move into serverless and shown you some of the reasons why you should and how you should get there, right? So I'm going to come at the second part of your serverless experience and talk about, once you made the decision, what are some key aspects that you have to keep in mind, and once things move into production, what are the kind of things you need to take care of. So I'll start by talking about some of the common mistakes people sometimes make when they once they made the decision to move to serverless and are on the journey, right? So one thing that I see typically with customers is you have the tendency to take everything that you have today and lift and shift and move it to serverless, right? This includes the architecture and the design. So you have an architecture which has worked for you phenomenally well in your existing infrastructure, and you try to replicate that with serverless. Or you have a code base that's built a certain way and geared towards a certain architecture. If your immediate reaction to moving to serverless is to kind of lift and shift and move that to a serverless architecture, that's going to be a little interesting and tricky, because What you need to do when you move to serverless is take advantage of the strengths of serverless, right? So that includes refactoring your architecture, changing the design, and also adapting the code base so that you can get the best benefits out of serverless. And those are a little hard to quantify upfront, but as you start through the journey and you iteratively break up your monolith and make up your existing application and break it up into smaller manageable chunks, and we'll see a little bit of good best practices when we come to that, then your architecture can take advantage of the serverless infrastructure and be more adapted and more agile that way. The other mistake, again, we've seen people do is carry over your testing practices the way you used to when you're building monolithic or non-serverless kind of applications. When you move to serverless, there are a few things change, right? So you are now not bound to an infrastructure that's always on, right? So sometimes things are spun up with Lambdas in particular only when you need it, right? What happens when you don't need stuff, right? So there is no metrics coming out of that system, right? There are many ways in which Lambdas have subtle differences in the way you from what you're used to, right? So, and that includes testing as well. So make sure you have a testing framework and a testing process in place that's more adapted to the serverless way of thinking and leverage and making sure you test the strengths of the serverless, right? So make sure you're not testing the incorrect things that's not meant to be tested with serverless, but focus on the areas that serverless is bringing advantages to. The other mistake we see is commonly people try to manage the serverless infrastructure. One of the promises that Sandy made previously is you don't have to manage a lot of things when you move to serverless, right? So you don't want to manage servers, you don't want to manage VMs, Kubernetes clusters. But if you move to serverless and you deploy hundreds, maybe thousands of functions, and if you're now thinking about managing those, then you are actually doing something that needs to be rethought about, right? Because ideally, you should not have the need to manage the serverless infrastructure. A lot of that is already taken care of. And again, we'll see a couple of ways in which different solutions can help you manage your serverless infrastructure. The other thing we are seeing is observed is an immediate reaction, a knee-jerk reaction when it comes to serverless. People form their opinion pretty quickly, right? Both positive and negative. We've seen a lot of places which try to move to serverless, and the first moment they hit a roadblock, they said, "Oh, this doesn't work, right? So we need to move back to what we are used to." And that's a typical human reaction to change, but be sure you're guarded against that, right? There will be people who wants to jump into a conclusion and say that, "Oh, well, we haven't seen the benefits of serverless." And that may not necessarily because you did something wrong. It's just that you have to go through the process. You can't just get the benefits of serverless just because you migrated a couple of functions there, right? So there's things that cannot be decomposed beyond a point, and you have to make sure you try it out in its entirety before you make an opinion about whether serverless is working for you or not. So refrain from jumping into a quick knee-jerk reaction about forming your opinion about serverless. So let's talk about some best practices, right? So what do you do when you want to move towards serverless? What are some of the things you can think about? Again, something we already talked about is think about the application in terms of asynchronous architecture, right? Make sure the application, the design, the development process is aligned with an asynchronous way of thinking. So it's not a request response immediate, right? You send a request, something happens, and then you are notified when the response is ready, right? So it's a mindset change, but that's kind of what the industry is moving towards, microservices and event-driven architecture, right? So asynchronous has to be baked into your way of thinking. The downstream systems, right? So you obviously can't have a function in isolation. It still needs to depend on a database, on an API calls. Make sure those systems can scale as well, right? So your bottleneck is not going to be the serverless Lambda that you wrote. It's going to be the API that this Lambda is going to invoke or depend on, right? Or maybe the database, right? So make sure those systems scale well, right? You can literally go from no traffic to millions of invocations very quickly, and Lambda will phenomenally scale well for all those scenarios. But can your downstream, your dependent systems do that? That's something you have to be sure that you plan for and answer upfront. Do one thing and do it right. Age-old Unix philosophy applies very well here, right? Functions make them as atomic as possible, make them do the right thing, one thing, and don't try to mix multiple things by building a monolithic function, right? The whole objective here, right, from a architecture perspective is breaking the monolith, making it into more manageable chunks, right? Now, don't go against that ethos by building monolithic functions that does more than one thing or multiple things at the same time.
So Nikhil, we've had this use case where one of our clients came back to us asking, there are too many lambdas at this point. Like once the application started growing, in about 6 months or so, there were just too many lambdas. And the client was basically asking if you could club a few of these or club them based on the module that the system is built on into a specific lambda. So what are your thoughts on that?
Good point there. So I think a lot of times people think about worry about the number of functions is because when they look at the AWS console and they see 1,000 lambdas, they freak out. But that's no reason for concern at all, because AWS doesn't care, and they can perform equally well on thousands of lambda, tens of thousands of lambda we have seen for customers. The thing that you need to kind of manage is how are these lambdas organized from your code base, from your development lifecycle, right? If you have, let's say, an account management service, right? You log in, you log out, you change password, manage your settings. Those are all logically related, right? Now, each of those would still end up being different functions, but you don't have to have a separate GitHub repo for each of these functions, right? So, and that's where the using a framework for your dev, test, and deploy lifecycle helps, right? So you can modularize your code base, different similar functions live together. They are still easily visible and manageable from a code and an organization and a design point of view as one single logical unit, but then you deploy it as individual functions. It's not a monolith when it goes to the wire, right? When it goes to the to the actual execution point. But your implementation might look monolithic if you squint at it, but it's still being deployed as individual functions. So it's all about picking the right framework, and that's where using a good framework for your dev, test, and deploy lifecycle would help you in that. And the other thing is versioning strategy, right? So if you have thousands of lambdas, it's you are going to change those lambdas frequently, right? And but you don't have to change all of them at the same time, right? So there are dependencies between them, right? So having a versioning strategy so that you can move all or nothing or handful of lambdas into production at different cadences, different frequency, all that helps, right? So planning for a versioning strategy definitely helps, or takes a long way into managing it eventually when it's in production. Now, from a deployment point of view and from a testing point of view as well, think of it, think about testing upfront, right? A lot of organizations do test-driven development, and that's great, perfectly suitable for lambdas. But if you're not, make sure you have some things in place to make sure you are testing as you develop, right? Yeah, so you don't want to deploy 1,000 lambdas and then figure out, okay, there is some dependency or something weird that's going on. Test each individual lambda individually. And to help accelerate that, give every developer a kind of like a pre-dev environment, right? So if I'm developing a Lambda, I can deploy it right away without worrying about breaking anything, right? And even if it breaks, that's fine because it's a pre-dev environment, right? So have those stages, have those best practices for moving code from different environments using CI/CD pipelines, DevOps, all those good practices, right? So make sure you adopt that. And it doesn't have to be something radically different. It's just using the best practices that's kind of adopted throughout the industry right now.
So that was a very nice point, Nikhil. So we did something similar, and this is a practice we follow. So for the dev, test, and production environments, we have a proper CI/CD pipeline which has all the rules in place, which is going to do your Sonar Cloud checks and other quality checks that were in place. But we also had a pre-dev instance, and that system is basically open. So you don't need a PR approval, or the PR process is not that stringent. And anytime a developer is doing something, first they test it in their local. But for things like, if your Lambda is communicating to an SNS or something gets uploaded to S3, you need to trigger a Lambda. So these things are very hard to test in local, right? So that's exactly where pre-dev comes into picture. So the developer will push the code to pre-dev, where there are minimal rules, and deploy it to an actual AWS environment, test it out, and then move on to the development branch and other items.
That's absolutely a great point too, because a lot of times what we see is people don't have that practice in place, and then they say, oh, I can't test anything anymore, right? And serverless doesn't work, right? So again, helps you get away from those knee-jerk reactions, right? So yeah, absolutely. Yeah, the next point here, we sort of talked about that, right? So make sure you load test your downstream system. There's no point in load testing your Lambdas because AWS is going to scale, right? We know that, right? So as long as your code doesn't have any infinite loops or something that doesn't exist, there's no point in load testing just your Lambda function in isolation. Make sure when you do that, or even if you don't test your Lambdas in isolation, make sure your downstream systems are load tested and able to scale to the level that you're expecting your Lambdas to scale. Now, having said all these good things about Lambdas, there are some things that usually people consider to be a problem with Lambdas. Usually it's cold starts and managing concurrency. Now, once you understand what what cold starts are and what concurrency management is, then things become a lot more easier, right? These are and there's a lot of ways, a lot of solutions and a lot of approaches you have to kind of get over cold starts and get over the problem of managing concurrency. Autonomously managing these things is one solution that we commonly talk about. But make sure you plan for this, right? Don't be painted in a corner where you're surprised and learn about all these things when you just move to production, right? So do keep in mind to test for cold starts and concurrency as you go through your development process. So supporting that point is using autonomous system for configuring production, right? Thousands of Lambdas. How do you even know what is the right memory configuration for every one of them? The short answer is you don't, right? Let an autonomous system do that for you. And another thing that surprises a lot of users is cost, right? You configure your Lambdas incorrectly and let every Lambda have 10 gig of memory available to it. Obviously, your cost is going to be a little higher than what you anticipated. So make sure you monitor for it and adjust. Make sure your autonomous system can aptly optimize for cost as well. And prepare for a tighter dev test deploy lifecycle, right? So things are going to be much faster because changing one code, a few lines in a function and deploying it is much easier than deploying a monolith or multiple functions in one single go, right? So your lifecycle becomes much faster. So just adapt to that. Some other best practices that we can quickly go over. Set a higher order SLOs, right? So once things are in production, right, you are monitoring things, make sure you have the service level objectives defined, right? And those should be aligned to your business goals. If you try to achieve SLOs based on your resource utilization, you're in for a hard time because there'll be so much metrics that you need to deal with. Make sure the key metrics that's important for you is identified and you just monitor for those. Like I said previously, always make this a problem of optimizing for both cost and performance. You need both, right? You can't just optimize for cost or for performance. And Lambda makes it very easy to do this, right? So make sure you plan for that and take advantage of that. Solve your cold start problems and concurrency problems with autonomous concurrency management systems. Setting timeouts. This is something we've seen a lot of people usually miss out, right? Set your timeouts based on experience, not based on what the developer thinks or the developer anticipates the timeout for execution to be. Let everything be data-driven in production. One of the things Lambdas allow is frequent releases, right? So make sure you have something in place to get a real-time intelligence on the releases and that they're all trending towards in the right direction. Lambda also makes you easy to move to ARM platforms, right? So if your code is not particularly tied to a certain architecture, make sure you take advantage of that because you get both performance and cost benefit at the same time. Use tracing tools. Xray is a great tracing tool on AWS, and that can help you a lot of reduce the amount of time you spend debugging issues, especially when it comes to performance issues. So having said all that, right? So one thing I've been trying to kind of promote here is to have an autonomous system to manage your infrastructure. Now, instead of going to this point, just to drive home what is the difference between automation and autonomous, right? Because when you talk to customers about autonomous systems, they actually say, oh, we have automation in place, right? So just to give an analogy for this, when let's say you're tasked with building a self-driving car, right? And let's say what you do is instead sit in the passenger seat and observe what the driver does. Is changing gears, is using the pressing the pedals, turning the steering wheels, right? and you just build a system that does exactly that, right? But sooner you very soon you'll realize that that's not where the hard part is. The hard part is actually deciding when to do this, right? So automation is more about changing the gears and moving the steering wheels, right? Instead, an autonomous system is something that can do that, and that's granted, that's a given. But the intelligence there is knowing when to do it and making that as a data-driven thing, right? Instead of just rules that let you define that. So that's what you need when you move things in scale into production using Lambdas. You need an autonomous system to manage it for in production. You needed to make sure the settings are always done right. You needed to make sure that you are always optimizing on cost, on performance, right? So as a developer or someone who is responsible for this product, once things move into production, then you don't have to worry about things, right? So that's kind of the goals of what you should look for in an autonomous system, and that's why autonomous system is important. So again, this is just kind of expanding on that, right? So there is always a sweet spot between cost and performance, right? So an autonomous system should always try to find out that ideal sweet spot where you get the best performance and the best cost possible. Now, all these are cold starts. We mentioned about cold starts and timeout management. These are all very, very real problems that people face in production, right? Not because you hadn't planned for it, but because the moment you start seeing 1,000 lambdas, it becomes hard for people to sit down and manage it. So this is some of the example use cases where autonomous systems can greatly accelerate your adoption in production. So what do you look for in an autonomous management tool? Somewhat, pretty much common sense things, right? An autonomous system should be able to drive you to a goal. You should be able to specify a goal and let the autonomous system find the right metrics for you, continuously monitor those metrics, and then take steps to achieve those goals, right? So exactly. So if I had someone who's going to take my orders and do something for me, right? How would I tell him to manage something in production? That's the kind of explanation or the inputs that I should give to an autonomous system. Essentially say, make everything work fine. Here, go get all the data that you want, but make sure everything runs fine, right? So that's the level of inputs that you need to give, and then you need to be able to see that in action and get an explanation on what steps were done to get to that goal, and then make sure these things keep on going on a continuous basis, right? So these are some of the things that you should keep in mind when you look for an autonomous system. And these are some of the driving forces, driving principles that we at SEDI followed when we built SEDI to autonomously manage your lambdas and your infrastructure in production. So real quick, I'll hand over to Sandy to give a demo of Handstack and the ASAP framework.
Thanks, Peter. John, could you enable the screen sharing? Yeah. Yeah. So at Handstack, we specialize at building serverless applications. And over the past few years, we have understood what kinds of problems an enterprise faces while moving to serverless. And we have also built custom libraries, custom programs to enable us to build these applications faster as well. So we have introduced a new program called Handstack ASAP, the Startup Accelerator Program. So what you get, why to choose this is one of the fastest way to put your product into the market. So using our custom modules and frameworks, we accelerate the development process and make sure you're able to deploy faster. Next thing is you'll be able to save a lot of cost again by moving into serverless. And we take care of the entire process from the design to the code to the launch. So from the UI till the after production support. So all of this is taken care by the program itself. And of course, with serverless, it's much more easier for you to scale, and there's no additional charge for scaling up or scaling down. So all this is taken care by the framework itself. Of course, with serverless, one of the factors which we talk very less about is the security. So most of the serverless services have their own security mechanisms in place. So all that security is built in with the system itself. So how does the program work? We connect with you, understand what is the business needs. Then we start creating the mockups for it and get the approval on how it needs to be done. Then using our pre-built modules, we accelerate the development, we deploy it to the cloud. And then after the production, we also provide the ongoing support for it. So here are some of our partners that we have developed over the last few years. And you can check out some of the case studies that are also available in the website, and also our success stories. So yeah, feel free to start the evaluation program and see if Einstein is your best choice.
Thank you, Sandy. And for people who are willing to try autonomous and take the next step, please do visit sedai.io. Our signups are free. You should be able to sign up and give Sedai a spin. And we'll be glad to work with you on that. So we are coming on the hour. So I got some questions here. I'll read the first question to you verbatim, Sandy, and let's see if we can figure this one out. So the question here is, I have configured AWS API Gateway and Lambda plus WAF to rate limit endpoints. The throttling values are 50 with a burst limit of 10 in the REST API Gateway. WAF is configured to rate limit by 100 requests in 5 minutes. If I have an async Python script and the Lambda still processes around 200 requests before rate limiting kicks in, is there a solution for this to limit it to 100? So essentially, if I can rephrase that, looks like you have Lambdas that WAF limiting to 100 requests, but you have asynchronous Python scripts, Python Lambdas that's serving it. So WAF does not, so the number of synchronous requests actually goes up to 200. So I think one solution for this might be setting up reserve concurrency and setting it to 100, right? So no matter how much request you comes in and whatever WAF passes through, you won't have more than 100 concurrent invocations on the actual Lambda. So I think that might be one option to answer that. Any other thoughts, Sandy?
Yeah, in line with you, Nikhil. So it's a small setting that's, I think this is one parameter concurrency, and you can set it per Lambda. The ideal, default limit is 1000 Lambda executions per region. It's a soft limit again that can be increased, but you can also configure it per Lambda, and you can rate limit it that way.
Sure. The next question is, does anyone use any offline testing framework for testing Lambdas? People use serverless framework, but it has its own challenges. So what's your recommendation, Sandy?
Yeah, so this is one of the first questions we get asked as part of the development. So for the offline testing, there's local stack, which has improved a lot over the last few years. It's supporting a lot more AWS services, and it is easier to use compared to other frameworks that are there. But we would still prefer using an actual pre-dev environment to make sure it is working in AWS itself. So first is local stack, if you want to make sure it's completely on the local side. And also SAM also provides you the ability to test Lambdas similar to serverless framework. But again, that's limited. Local stack is much more advanced than that. But 100% surety you will get only when you deploy to AWS. So a pre-dev stack would be the best way to do it.
Okay. I see another question which says, does Sedai lead to CloudWatch builds? Okay, I'll take that one. So assuming the question is, when you use Sedai, does that increase your cost in terms of CloudWatch builds? And the short answer is no. The more nuanced answer is just by a little bit, right? So if your cloud spend is, let's say, $1,000 a month, Sedai would probably cost you like $1 or $2 in terms of AWS bills increase because of Sedai using CloudWatch. So essentially, what we have done over a period of time is we have figured out all the right metrics and the right information that we need to track, the cadence at which we need to track, right? So because of that, we don't need to hit your AWS CloudWatch and download every single piece of data there, right? So it's much more nuanced and much more curated, so that the the bill that you get because of Sedai is typically just rounding error in pretty much all cases. So yeah, so Sedai does not add an overhead in terms of CloudWatch bills. Okay, right. I think we are coming on to the hour. John, any closing words?
Yeah, I think we've covered all the questions there. I thought in particular the testing framework was a good general one for many folks. I think it's serverless. So yeah, thanks very much everybody for attending. We'll follow up via email with a couple of links that we shared here today, and also the video here will be live on LinkedIn, YouTube, and our website within a day or so. So thanks so much for joining everybody, and look forward to joining you again on our next event. So thanks Nikhil, thanks Eddie, and thanks everybody. Bye now.
Sure.